Hi, in this video we're going to be talking about how Juniper names its interfaces and some of the properties and how we track the state of an interface. So let's begin with the naming. So for example, let's see what I have here. I have this naming example xe-0/1/2. So to understand what this means, we actually have to understand a little bit better how Juniper names the different components on their devices. So let's see this with a diagram. So I'm going to draw here, let's say, a J series router, so something like that. I'm going to draw a chassis type device. So that'll be our J series device. Let's draw here a line card. Let's draw another one. This is a way of actually getting the concept much faster than if we just mention it. So, for example, let's say this is my J series router. So remember that J series router typically has 4 gigabit Ethernet ports fixed on the device, and then it has 3 slots for cards. Those slots are called PIM, which stands for Physical Interface Model. So on other Juniper devices, we actually have what's called a PIC, which would be this part, and then the line card itself would be called FPC. So FPC stands for Flexible PIC Concentrator, and PIC stands for Physical Interface Card. So basically we could have an FPC with 4 PICs, and each PIC could have, let's say, 4 physical ports. You could have less, you could have more, depends on the actual configuration of the FPC. So let's remember that, for example, in the J series, the idea of these slots is to give us more flexibility. We know that we have 4 interfaces, but maybe we need more, or we need an interface that's not Ethernet. Think about it like DSL interface or T1 or an E1 interface. So that's the idea behind that. And same here on the actual chassis devices. So if we take my example, which was xe-0/1/2, let's say that this is 0 and this is 1. So what information are we getting from that? We're getting some pieces of information. In concrete, it would mean this means the interface media type. So for example, XE represents in Junos a 10 gig interface. So if this was a gig interface, it would be GE. If it was fast Ethernet, it would be FE. So what other information are we getting actually from this naming? So we're getting that this is port 2 of a 10 gigabit Ethernet PIC in slot 1 on FPC 0. So let's see that again. So this is the actual port. This is our PIC, and this is the FPC. So with this information and looking at this diagram, so where is this interface? So we can actually say that it's here. It's the second port if we have 4 ports here. It's this second port here, because this will be PIC number 1 and this will be FPC 0. So the good thing about it is that this naming scheme is quite consistent on most Junos devices. So once you get the hang of it, it's pretty much standard for all the other devices. So it's very intuitive as well. So you don't actually need to have ever seen the device to, if you remember that it's the FPC PIC and the actual port, and that the beginning stands for the media type, which in this case is a 10 gig link, you can very easily understand where on the device that port is. So next, we have the logical units and the family and the families on the interfaces. So let's talk first about the logical unit. So a logical unit is how Juniper approaches sub-interfaces. Every single interface on a Juniper device needs to have a logical unit. Typically, it's .0. It can be whatever you want. And if you have an interface that needs to have multiple what you would call sub-interfaces in another vendor, you would just have several logical units. And you can actually see it on the configuration. Let's see one router here. If we do show configuration, we can see here that interface EM5 has unit 0, which is the logical unit, configured, and under that it has his family inet, which we will talk about in a little bit, and then the IP address. So I could define another unit on that particular interface. A common example of this is think that you might have something like a trunking interface where you're passing several VLANs and you want to have several logical interfaces for each VLAN. So you would do something like that. You would do EM5 unit and then an identifier, which typically is the number of the VLAN. It doesn't have to be, but it's done for clarity. So you could have that, and under each one of those units, you could have a different configuration. So great, that's what logical units are there for. So what's family? Well, family is basically the way that Juniper has of keeping their consistent configuration model. So basically, a family means a protocol. So you can actually see it. If you do, let's go into configuration mode and we do set interfaces. Doesn't really matter the interface .0, which basically it's a shortcut for unit 0. You could do it as well, like unit 0. And then you go family and you use a context-sensitive health. You can see we have several protocols here. We have the most interesting ones are, of course, IPv4, which is inet, IPv6, which is inet6 or inet6, and MPLS. So in this way, we could do family inet and do our IPv4 configuration, different parameters, different things we could do under there. And if that interface is also using IPv6, which, for example, it's a dual stack type of environment, we could go family inet6, and it's completely separate, and it gives us that nice level type of configuration we are used to in Juniper. So it's a very useful and it's a very nice feature. Some of those options are mutually exclusive. Obviously, you can have an interface speaking every single protocol on Earth, but for example, things like IPv4 and IPv6 can coexist. So let's talk a little bit about the different properties that an interface can have. An interface, as you well know, can have two types of properties, physical and logical. So what do I mean by physical? Well, things like data link layer protocol, the speed, the duplex, the physical MTU. So this is where we say, oh, this interface has an encapsulation of PPP, or it has an encapsulation of Ethernet, or it has an encapsulation of frame relay, or whatever your layer 2 protocol is. And you could specify things like, the speed, the duplex. If we are in Ethernet and for some reason we don't want that to be auto-negotiated and we want to hard-code it, we could actually do it under the physical properties. And the logical, still things like addresses, circuits, if you're running things like DSL or you're running things like frame relay. And finally, to see what's, there's many ways, or there's a couple of ways of actually seeing what the status of an interface is. There's one single very useful command, which if you come from the Cisco world, it's equivalent to show IP in brief. And that command is show interface strs. So let's see here, let's get out of configuration mode. If we do show interface strs, we get a lot of information quite quickly and quite nicely for all the interfaces on the device. So first we're getting here what interface, we're getting if the interface, what's the admin status, so is that interface deactivated, or if that interface basically shut down. Do we actually have link on that interface? What protocols are configured under there? We can see for here in EM5.0, which is the management interface for this device, has IPv4, and we can see the address it has, and then we have this internal loopback which actually has both. So it has IPv4 and it has IPv6. So single command, quite easily, quite fast. You can see different properties for all of the interfaces in your device. So very good stuff. So summing up, we talk about how the naming scheme on the Juniper works. We talk about what's a logical unit, what's a family. We saw the different properties you can have, both from physical and logical, on an interface. And we saw a command to actually kind of wrap it all up and see very quickly the state of all the interfaces on the system. Thank you.